All right, we're going to combine lesson 1.8 and lesson 1.9. These are the first two sections in Unit 5 on patterns, equations, and graphs. We're going to verify that a value is or is not a solution to an equation, and then we're going to use tables, equations, and graphs to describe relationships. So this unit, we're going to be solving equations, but we're going to be doing it through word problems. All right, for number one, it says to tell whether the given number is a solution to each equation. So in order to determine if a number is a solution, we have to plug it in to the equation and see if it makes the equation true. So we have 9 equaling 2a, but instead of writing the a, we're going to plug in 3 plus 3. And so we have 9 equals 2 times 3 is 6. 6 plus 3. And so you see we have 9 equals 9. So 3 would be a solution. It makes the equation true. Alright, for the second one over here, we're going to plug in a 7 for n. So we have 5 times 7 minus a negative 30 equaling 5. So we're going to have 35, and then we're subtracting a negative. That's the same thing as adding a positive. Alright, so we have 35 plus 30. Okay, so this double negative becomes a positive. So this is going to give us 65, and that does not equal 5. So 7 is not a solution. Okay, it does not make the equation true. Okay, let's go to number 2, and this is where we're going to be given a word problem and be asked to solve an equation. So the money a company received from sales of their product is represented by the equation y equals 45x minus 120. Where y is the money in dollars and x is the number of products sold. And then it asks us to answer a bunch of questions. Before we answer those questions, we're going to go over to 2b, and we're going to take the equation from 2a and solve for x. So we're going to write y equals 45x minus 120. You know what? Let's keep that there. Let's go ahead and let's answer these first. Alright, so how many products does the company need to sell in order to receive $780? So if you notice up here, y is the money that the company makes in dollars. So if they want to make $780, how many products do they have to sell? We have to take the 780 and plug it in for y. So we have y equals 45x minus 120. Substitute 780 in for y. Okay, and now we solve for x. So we got to get x by itself. So in order to do that, we first are going to add 120 to both sides. And that's going to give us 900 equaling 45x. That cancels. Alright, I'm going to come up here. I'm running out of space. So 900 equals 45x. I got to get this x by itself. So I have 45 times x. What undoes multiplication? It's inverse operation, which is division. Will help us do that. So we're going to divide both sides by 45. And so we have x equaling 900 divided by 45, which is equal to 20. So our answer is 20 products will yield the company $780. Okay, the next part, it says, what does the slope represent? Well, slope equals rise over run. Our slope is 45, so our slope is it's 45. Alright, so we're going to write 45 over 1. Now, the rise, what's being graphed so along the y-axis? It's the money in dollars. So we have money, so the over, and then so our rise is what's being graphed on the y-axis, so that's money in dollars, and then the run is what's being graphed on the x-axis, which is the total number of products sold. Alright, so we have the money per product. That's what the slope is telling us. So it's saying that they make $45 for every one product sold. Alright, so we're going to write that down. We're going to use a different color to make it easier to see. Slope represents money received per product. And in this case, $45 per product. Alright, so the slope represents money received per product. So they get $45 for every one product. So you have $45 per product. Alright, now what does the y-intercept represent? Alright, so negative 120 is your y-intercept. That's your initial value. So what the y-intercept represents in problems like this is how much money it is to make the product. So the company spends $120 to make the product before it can sell it out. So we're going to write y-intercept represents the amount of money it takes to make the product. Alright, now we're going to come over to 2b. Alright, and we're going to just solve for x. So in this problem, it says, like, we already have y solved for. So the equation is solved for y. We have y by itself. Now we want to flip that, and we want to make it so x is by itself. Alright, so we're going to add 120 to both sides. So we're going to have y plus 120 equaling 45x. And now we're going to divide both sides by 45. that cancels, and so we have y plus 120 over 45 equaling x. Alright, so there x is by itself. We've solved for it. We could rewrite this as y over 45 plus 120 over 45. We could reduce that. I'm not going to. Equals x. So either one of these, would be correct. Alright, in problem 3, it says there are 450 people traveling to watch South's playoff football game. Each bus can seat up to 55 people. Write an equation that represents the number of buses it will take to transport the Rebel fans. Use a table to find a solution. Alright, so let's define our variables first. So let's say y equals the total number of people. And then our x, right, that's going to be the total number of buses. Okay, so we can write an equation for this problem. So the total number of people, so our y, is going to equal, now how many people can fit on each bus? It says 55. So y is going to equal 55 times x. So 55 times the total number of buses can give you, the total number of people that, can be transported, total. Okay, so now though it says write an equation. Okay, we did that. Write an equation that represents the number of buses it will take to transport the Rebel fans. So we would just substitute in 450 for y. So we know there's 450 people going. So we're going to say 450 equals 55x. Okay, so there's your equation that models this problem. This equation, if we solve for x, it's going to tell you how many buses you're going to need to transport the fans. Okay, so we can solve that, or we can use a table to find the solution. Alright, so we'll do that. Let's do it. We'll do it both ways. So let's create a table. Alright, and so again, x represents the number of buses, so 0, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so if so now we're just plugging in these numbers into this equation for x. So if you plug in 0 for x, 55 times 0 is going to give you 0. If you plug in 1, 55 times 1 gives you 55. So it's giving you the y is the total number of people that can be bused. If you plug in 2, you're going to get 110. So we need to get up to 450. If you plug in 3, you get 165. 4 is 220. 5 is 275. And then we go 330 we go 385, we go 440. Well, we need to move 450 people. So we're going to have to go one more spot here. Alright, so nine buses can move 495 people. Okay, so notice that you're going to have to take, so if you take 8 buses, you can only 440 people can travel. Well, there's 450 people, so you're going to have to take 9 buses. That 9th bus is going to have some extra room. So it will take 9 buses. Okay. And then we can arrive at that answer by solving this equation. So we have 450 equals 55x. We can divide both sides by 55. Alright, so we would get 450 divided by 55. So we're going to get x is approximately 8.2. So this is an exact, this would be an exact answer, so well, this is an approximate answer, I'm sorry, but like 8.2, you can't take, 0.2 of a bus. Alright, so that's why we would have to round up to 9 here. Alright, but here we solved by using a table. Here we solved by solving the equation. Alright, the next part. Okay, we kind of go back to where we started. How can you tell if an ordered pair is a solution to an equation? So when you plug the ordered pair into the equation, it makes the equation true. Alright, so that's how you can tell. What does it mean? I mean, it's similar, so we're not even going to get into that. Okay, so for number 4, it says tell whether the given ordered pair is a solution of the equation. I want you guys to go ahead and do these two on your own. Hit pause, knock them out, and then resume to check your answers. Okay, so you should have gotten both of them to be solutions. Alright, so here in problem 4, you're plugging now 2 points into the equation. You're given an ordered pair, so you plug the 1 in for x and you plug the -3 in for y. And same thing here, plug 6/5 in for x, plug 2 in for y, and then make sure that the left hand side of the equal sign is that of the right. Alright, number 5, it says a pizzeria charges $12 for a large pizza plus a $3 delivery fee. You are interested in the relationship between the number of pizza delivered and the total cost. Alright, and it says to first, in part A, define your variables. Alright, so we are going to let y be your total cost. Okay, y is usually what you're trying to find. Your x, that's going to be in this case, the number of pizzas. Okay, so y is the total cost. X is the number of pizzas. Okay, I'm gonna come down to C before we do B. It says use an equation to represent this relationship. All right, so y, our total cost, is going to equal, well, it's going to be equal to 12 times x. So it's $12 per pizza. So 12x. But there's also plus a $3 delivery fee. All right, so that is your that's kind of an added-on charge. It is not dependent on it's $3 no matter if you buy one pizza, two pizzas, three pizzas. All right, so that's just going to be our constant. So we're going to add that on at the end. So 12x plus 3. So that's going to be the total cost that you're going to owe. All right, so now we're going to come back here and do our table. All right, so if we buy one pizza, plug 1 in for x, so 12 times 1 is 12 plus 3, so that's going to be $15. Plug in 2, you're going to get 27. You go $27. Plug in 3, $39. And then plug in 4, $51. Plug in 5, you go 63. Alright, so there's the table to represent the relationship. And it says how much is your total cost if you buy 7 large pizzas and have them delivered. Alright, well, let's continue with our table. So 6, plug in 6, we're going to owe 75, and then plug in 7. And we would owe $87. Okay, so it should be $87 that we owe. Now let's do this, let's solve the equation, and just to confirm. So 7 large pizzas, we want to know what the total cost would be. So we're going to substitute 7 in for x. So 12 times 7 plus 3. So y equals 12 times 7 is going to give us 84 plus 3. So y equals 87. So $87. Alright, for the last one, number 6. So it says write an equation to show the relationship between the number of runs and hours. So the number of ski runs, as it pertains to the number of hours. Find the amount of time it will take you to make 11 ski runs. Alright, so we got to create an equation, so we need to define our variables first. So what it is that are we trying to find? We're trying to find the total number of ski runs. So that's going to be what your y is. And then our x is going to equal the number of hours. Alright, so if we look at the table, so we can see that for every half hour you can make 1 ski run. You see that? So every half hour you can make 1 ski run. Okay, actually I made a mistake here. So we're actually trying to find the variables are different. So hours is H, ski runs is R. Okay, so let's say H equals hours and R, so number of hours, and R equals total ski runs. Okay, that's better. So now what are we trying to find? The amount of time. So we're trying to find H. So H, the number of hours, is going to equal 1/2 times R. So notice if you go on one ski run, it's going to take a half hour. Okay, so now how long will it take you to make 11 ski runs? So H equals 1/2 times 11. So H equals, so do 11 divided by 2. So 5.5. So 5.5 hours. Alright, that was a long one. So thanks for staying with it, and we'll be answering any questions you have in class.